Kobe, you can create your own custom content and share it with your students. And that includes the auto-graded coding projects. In this video, I'll show you how to create a Java auto-grader question. First, navigate to the course where you want to add your content. There are two ways to do this. You can either click the See More button next to the course name, or click into the section and then enable edit mode. From the side navigation menu, click to add a new page. In the unit view, expand to see the topics, then select Add Task Page. Let's give it a title, Java Autograder String Match Example. Here we have several content types to choose from. For this example, let's click on Code. Enter the name of the content, then choose the code from the dropdown. For this one, it's Java. Then select the question type. It's autograde. Then choose the type of autograder. And there are two types. First is string match. It's a simple output comparison method where you evaluate the output with the expected output. This one requires the project to have a print statement. Second type is the test file method. This uses the JUnit library and is great for testing methods and complex logic. This tutorial will cover both, starting with the string match type. Save. Here we have 3 panels. Let's collapse the left navigation menu for more space. On the left, the Explorer panel is where you manage files and folders. You can create or delete files. There are 2 file sets you can work with. First is the question files. This is what your students will see and work with. Let me show you. Let's write a simple prompt. This is what the students will see. All code is auto-saved. Click Preview, and here it is. The next set is the solution files. This is for your reference only. It's great for testing your code without affecting the student-facing version. Whatever you do here won't impact the autograder. The center panel is the code editor. On the right is where you insert the prompt and set up the autograder. In this example, we're going to ask the students to create a simple Python program that takes user input and outputs it in a certain format. I'll enter my prompt in the question box. The user will be asked what their name is. Then, when the name is entered, we'll greet them with their name in this format. Hi, comma, space, name, then exclamation mark. For example, when the program is executed, it'll immediately output, what's your name? Then the user enters their name, Jose. And the program will output, hi, comma, space, Jose, exclamation mark. Let's test out the full code in the solution files mode. As mentioned previously, this is for your reference only to test your code. And here is the solution code. Let's test it out by clicking on the Run button. What's your name? Jose. Hi, Jose. We've got the output we wanted. Next, let's design the student-facing side by switching to the question files. What I usually do here is I copy the solution code and use part of it as a starter code for my students. Copy and go to the question files, paste the code, and remove what you want your students to figure out, and insert instructions as needed. Note that the main.java file is always executed first. Now let's set up the autograder. This question takes user inputs, which will affect their outputs. So check the box for user inputs. The inputs will be entered in real time, and the output and the expected output will be evaluated. Click on the +add button to add the test input and the corresponding output. You can add multiple test sets. You can copy the output from running your solution files, or since this is an easy one, I'll just type them in myself. Here's the first set. Input Jose. The expected output should be Hi, Jose. Let's add another test. Input Tara. The expected output should be Hi, Tara. Enter hints and explanations as needed. We are all set here. We can test our code right here, or A better way is to simulate exactly what the students will see by clicking on the preview button. Enter the code. And the run button here, once again, is for testing purposes. If you want to get graded, click submit. Real-time grading, and it worked. Our Java string match autograder is all set. Now, what if the project doesn't require any inputs? Let's create a simple program that asks students to create a program that calculates the average score of the scores in an array. Here's the starter code. Note that in the complete code, there has to be a print statement. For this question, there's no input and there's only one output. Make sure the input box is unchecked. Enter the expected output or the average score, which is 86.6. Let's test it out by clicking on the preview button. Enter the code, submit to get graded, and it's working. Next, let's create an auto-graded project that can handle more complex programs using JUnit. Let's create a task page. Go to Unit, Topic, Add Task Page. Let's give it a name, Java AutoGrader JUnit Example. The type is code. Let's give it the same name as the page. Code type is Java. Question type, AutoGrade. Method, test file, and save. Let's collapse the left menu for more space. Here we have 3 panels. The Explorer panel is where you manage your folders and files. Center is the code editor. The right panel is for adding prompts, hints, and explanations for your students. Let's take a closer look at the Explorer panel. You can add or remove files and folders, and can choose which set of files you want to work with. There are 2. First set is the question files. This will load up files that your students will be seeing and will be working with. So if you want to give your students starter code, this is where you'll insert them. Also, students are not able to add new files, so they need to be preloaded here. The solution files are for your reference. It's always a good practice to keep a set of solution code somewhere where you can easily reference. These files won't affect the grading process. Note that there are 2 Java files created for you. Main.java is always executed first. Grader.java file is used for grading and uses the JUnit library. This file calls the methods created in other files, and it is used for grading purpose. Here's the task that we're going to assign to our students. Create 2 methods, add and multiply. Each method should take 2 parameters. The parameters are 2 integers. Add should return the sum of 2 integers. Multiply should return the product of the 2 integers. Note that the resulting value is returned, not printed. For example, add 8,2 should return 10. Multiply 8,2 should return 16. Make sure to declare your method names, add and multiply. Using the exact method name is very important. We need to call these methods to test them, so their names should be the same as what we use in the Grader.java file. Before working with the question files, which the students will be seeing, you can begin by entering the full solution code in the solution file set. However, this is for your reference only, and for this tutorial, we'll skip this stage. In the questions file set, let's create a 3rd file that the students will work with. The name is calculator.java. Then let's set up the main.java file. Enter what the students will see. It'll simply instantiate the calculator object. Then let's add some starter code to the calculator.java file, which the students will work with. Add comments or partial code so students can complete the rest on their own. Here we have instructions that's commented out and 2 method signatures to help students get started. Next, let's move on to the Grader.java file. Note that the Grader.java file uses the JUnit library, which allows you to create tests for all sorts of cases. If you want to know more about how to use this library extensively, search JUnit. There's a sample code in the Grader.java file that shows you some of the most popular JUnit functions. In this example, we'll use AssertEquals. Here's the Grader.java code for this task. It looks complicated at first, but it's pretty easy to work with. Let's look at the code line by line. Import static org.junit.Assert.assertEquals. This imports the AssertEquals method from JUnit, which is used to check whether the actual result equals the expected value during a test. Import org.junit.Test imports the @test annotation from JUnit. It marks the following method as a test case, so JUnit knows to run it when tests are executed. So for each test, make sure that @test precedes it. Public void evaluatesExpression. This defines the first test method, named evaluatesExpression. You can give it other names. Calculator C, new calculator. This creates an instance of the calculator class. We need this object so we can work with add and multiply methods. Int sum is assigned c.add 2,5. This calls the add method on the calculator with arguments 2 and 5 and stores the result in sum. Assert equals 7, sum. This checks whether the sum is equal to 7. If they're not equal, it will throw an error. Now let's test the autograder. Click Preview, then complete the task. Then click Submit. It worked! All set and good to go.